but it'll be a good show. We could do the whole entire show about it. It was really fascinating. Time for some more kitchen table astronomy. At the kitchen table in Amherst of Hampshire College astronomer Dr. Salman Hameed, who we lovingly call Mr. Universe. You've heard of Pizza Hut. Now we'll hear of Fomalhaut. What is Fomalhaut?
Okay, so Fomalhaut is a star. It's actually one of the brightest stars in the sky. It's the 18th brightest star.
In our sky every night, and I've never even heard of it?
It's not every night, but it's a little bit to the south. And so it sort of like, you can see it in the south, but it doesn't go all the way up north. And so, as you know, we have a northern hemisphere bias.
Yeah.
And so we don't talk about it. But it's a star that is not that far away. It's only 25 light years from us. Mm-hmm. So relatively...
Which, let's put this in context. For not far away, it takes light, which is the fastest thing in the known universe, 25 years to leave that star to get here.
Right, but
That's close in astronomical terms.
But to put it in context, even the center of our galaxy, the same galaxy in which we live in, that is almost 30,000 light years away. So
everything is so big.
Yeah, exactly. And we're not even talking about nearest galaxies or farther away and the farthest galaxy. But Fomalhaut, we are butchering the name. The original name is from Arabic, and I'm going to butcher the Arabic now.
Okay, good.
I think it's like, all...
It's only fair.
It's only fair. It's Fomalhaut, which means the mouth of a fish.
Uh-huh.
And in fact, it goes to...
Is that why you're wearing a fish shirt? And you gave me coffee in a fish mug?
That's exactly right. Today.
Do we have to listen to that obnoxious Vermont band now?
Wow. I'm not going to say anything about fish.
Your Ben & Jerry's ice cream, though, is excellent.
I love it. Absolutely. Okay, we got digressed about it. But, so it's the mouth of the southern fish. So it's actually Al-Janubi in Arabic. But this is a star which has been well known. As I said, it's a close star, 25 light years away, one of the brightest stars. But where it got its fame recently was the fact that in mid-2000s or a little bit after that, astronomers detected a planet, an exoplanet around it. In fact, this was the first, and I'm going to use air quotes, so for radio you can imagine, the first exoplanet to have been imaged. And I'm putting air quotes on to have been imaged. As it turns out, there was no exoplanet.
Oh, dang it.
And so it disappeared, in fact. So exoplanet was 2008. It was discovered, and they thought, okay, they found it. And in fact, the image at that time, sort of like, it was sort of like, you can see some dust around it, around this star. And then it was dubbed the Eye of Sauron.
Yeah, because we looked at these pictures of it. We can put some pictures up there. The Hubble picture and the James Webb picture, scary looking eye.
That's right. And then it kind of disappeared. And so now astronomers think that in fact they know that in fact was not a planet, but rather a dust cloud in there, and it dissipated, and which is very highly unusual. So what is going on? Why are we talking about it, and why was there? They thought there was a planet and it went away. Well, there is this protoplanetary disk around this star. This star is a little bit bigger than our sun. It's about twice the mass of our sun. It's going to live about 1 billion years compared to our sun, which is going to live about 10 to 15 billion years. So this is relatively short. I mean, there are stars that are much bigger than our sun that live much shorter lives. This is sort of like, a little bit younger. Mm-hmm. And right now, it's going through its middle age. It's about a few hundred...
Did it buy a Ferrari?
Right. Well, that's probably what astronomers think is going on. There's midlife crisis. So this is a case where I think last week, Monte, you and I talked about the end stage of a star, and we were trying to figure out what's going to happen to our sun. Our Earth and our sun. And we were thinking about sort of like, the sun is going to expand and maybe it's going to swallow the Earth. Well, this is a case where we are more now looking at the earlier stages of a star, and we think our own sun formed in a similar kind of protoplanetary disk, and we think that we are seeing it here as well. Except what's fascinating, what Hubble found, what James Webb Space Telescope found, because James Webb Space Telescope is fantastic in looking in the infrared. And these dusty disks, they emit a lot of infrared light. And James Webb not only can detect it, but also can see through some of the disk to see in high resolution what is really going on. And the James Webb Space Telescope recently found that it doesn't have just one, this protoplanetary disk, just one, but in fact there are multiple rings around this star. And so what they think is that there is an inner ring, which is kind of like our asteroid belt. I mean, you can think about our own solar system to have a ring, because the asteroid belt is between Mars and Jupiter, and that is sort of like pieces of rocks that never could coalesce into a planet. And a lot of it has to do with Jupiter. Jupiter's gravity actually prevented this material to coalesce into a planet, so it sort of like stayed in this form. And we think that in this star, Fomalhaut, a similar thing is happening, that there is an asteroid belt kind of thing. This is the inner thing, which is close to the star, but then there is an outer ring as well. And then there is, now astronomers have also found an intermediate ring. And what is going on is that we cannot see planets in between. So when we are talking about multiple rings, obviously there is stuff in between that has been cleared out. And the material that has been cleared out, whenever astronomers see that, and this is also, you can see it in Saturn's rings, that there are these gaps, and usually in those gaps there are tiny moons or something like that that is clearing out material. Same thing, astronomers think that in between those rings, you can think about the asteroid belt or Kuiper belt, sort of like that type of thing, there may be planets around it, but James Webb Space Telescope, even the great James Webb Space Telescope, doesn't have enough sensitivity to detect smaller planets. Like even if there is a Jupiter there, they cannot detect it.
So are we saying that what we're learning from the James Webb Space Telescope is the formation of what could be a solar system not unlike ours, where these planets or potential planets are in process? Are they going to stay as an asteroid belt? Are they going to coalesce into their own planets? Or we don't know?
Wow, this is what's going on. This system, Fomalhaut, why it is so interesting is that it is still dynamic. Now, our solar system, in some sense, we are also middle-aged, by the way, because we are 5 billion years old.
I feel it every day.
Exactly. But it's relatively stable. Asteroid belt, well, it's what the asteroid belt is doing. And Kuiper belt, which is beyond the orbit of Neptune, that is there, that is what that is doing. But in Fomalhaut, there is a lot of activity going on. And in fact, in the new James Webb Space Telescope image as well, there is a giant dust cloud in there. Another one. That's the different one from the previous lost planet one. There is another one that is in there. And they think that these dust clouds are formed by colliding bodies, ice and rock bodies like asteroids colliding with each other. And then this is the debris that is falling in. Now, this is relatively rare in our solar system. And in fact, this is our solar system overall. First of all, it has two rings in that sense. I mean, asteroid belt and then the Kuiper belt. But overall, it's stable. In this particular star system, if you are a planet, well, you are in trouble. Say, for example, in those gaps in between that, because what it means by clearing out the material is that you are actually being hit constantly or relatively more frequently by asteroids and things like that. So this is a troubled middle age. This is a star that is buying a Ferrari.
It's Fomalhaut, which, I'm glad that it's still hot, at least in middle age.
And actually, it is, temperature-wise, it is much hotter than the sun because it's a little bit bigger as well.
It's also got a great personality. So
exactly.
It's got potential for the rest of its life.
But I should also mention another thing, that here is a case where, when we talked about that, well, astronomers had thought they had detected a planet. And then they said, oh, actually, it wasn't a planet. In fact, this planet was, in fact, given a name as well. There was International Astronomical Union recently had sort of like, conducted and sort of like, it had given options to many different countries to name exoplanets. And this was actually one of those stars and a planet. And in fact, this was officially given a name of Dagon, which is apparently sort of like, from other... it comes from some other legacy, not from Lord of the Rings.
Despite the fact that Fomalhaut looks like the Eye of Sauron.
Yeah, exactly. I think it's some Semitic deity. But anyway, so what I wanted to emphasize is that is how science works. Meaning to say that sometimes you observe things again because people are constantly checking the results. So exoplanets, it's not that exoplanets have gone away. We didn't know they were exoplanets. Now we have about 5,000 of them. But occasionally, these things also happen where you go like, you know what? That actually was not a good measurement, or that turns out not to be a planet. But, and so sometimes people react to it and say, oh, science. One day it says one thing and the other day it says another, and we can never trust it. But I want to, again, bring up this context that this idea that planets around stars form in these protoplanetary disks, that idea goes all the way back to late 18th century. And this was given by Immanuel Kant and Laplace, the famous mathematician also. And they actually suggested that probably our own solar system formed where there was a disk around it because it formed from a gas cloud. And it was through this disk that material coalesced into planets. So this was an relatively old idea, and now we have very, very good evidence from looking at many other protoplanetary disks to see that this is what happened. So there is also this element that today nobody doubts that solar systems form or planets form out of protoplanetary disks, including our own system. So yes, occasionally you go back and forth because that is how science works, but also we do make certain claims as well, and those certainties keep on getting increased the same way we know exoplanets exist. It is not a question.
If we want to take a look at this 13th brightest star in the
18th.
sky, if we want to take a look at this 18th brightest star in the sky, where should we look?
Oh, this would be in the fall, and it would be towards the south. And because it is actually towards the south, and it doesn't go up that high, so you will have to have a clearer horizon towards the south, and that's where you'll be able to see. But you will have to wait a few months.